going to talk about all of the divisibility rules from 2 to 11. We're not going to talk about 1 since everything's divisible by 1. Okay, so let's start with 2. So if a number is going to be divisible by 2, it has to be even, like 3,422, for example. So I'll look at the last digit. It's even, so 3,422 is divisible by 2. But what about 3,423? Well, now if I look at the last digit, it's odd. Odd numbers aren't divisible by 2, aren't divisible by 2. So 3,423 is not divisible by 2. So what about 3? Well, we already focused on that one. Like, if the sum of the digits is divisible by 3, then so is the number. Like 555. I add 3 5s, I get 15. 15 divided by 3 is 5. So 555 is divisible by 5. Is divisible by 3. So what about 556? This time, if I add digits, I get 16, which is not a multiple of 3. So our number is not a multiple of 3, so it's not divisible by 3 either. So let's check 4. We haven't talked about this one yet. There's actually 2 rules for 4. The first one, I know 4 is 2 times 2. So every multiple of 4 has to be a multiple of 2. So I just have to find out if the number can be divided by 2 times. But here's a more strategic way. It's a little more sporting. We look at the last 2 digits of the number. If the last 2 digits is divisible by 4, then the number is divisible by 4. And if the last 2 digits is not divisible by 4, the number is not divisible by 4. So let's check out why. For example, 32,428. I look at the last 2 digits, I think, hey, I can split it up so that it's 32,400 plus 28. Well, why don't I split it up into this big 32,400? Well, what's special about 4? What's so special about 4? Well, 100, it's easy to multiply by 100. 100 equals 4 times 25. So, if I have this big hunk, I see that 32,400 is divisible by 100, then it's also divisible by 4, since I just counted by 25s, all the way up until I get this big hunk here. So, every multiple of 100 is divisible by 4, so I don't have to care about this. All I care about is the last 2 digits. So if I add a multiple of 4 to a number that's not a multiple of 4, I get a number that's not a multiple of 4. But if I add 2 multiples of 4, I get another multiple of 4. So that's why. Get it? So what if I had a number like, I'm not sure how you say this number, let's just say 1,068,405. The last 2 digits of the number, they spell out the 5. I know 0, 5, but spell out 5s. 5 is not divisible by 4. In fact, it's not even. That's the funny part. Anyways, so how about 5? Well, we hadn't talked about 5. That's because it's way too easy. You just see if the number ends in 0 or 5. So if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 ends in 0, divisible by 5. We don't really care about whatever's up here. Oh, it's kind of the same thing with 4, only we don't really think of it this way, since any multiple of 10 is also a multiple of 5, since 10 is 2 times 5. Okay, we don't really think of it that way, but that's why we have to 0 or 5. And again, if I change this to 5, still divisible by 5. Let's try another number. If I had 5, 4, 3, 2, 1. 1 is not 0 nor 5. So 5, 4, 3, 2, 1 is not a multiple of 5. So that was pretty easy. What about 6? 6, there's no other way. It's similar to the 4. Since 6 is 2 times 3, the number has to be even while the sum of its digits is divisible by 3. So basically what we're saying here is the number has to be divisible by 2 and divisible by 3. So let me think of a number. Maybe, I didn't get my point. If it's a small number like 18, I know it's pretty small, but here's basically what we mean. 18, it's even, and 3, well, 1 plus 8, 3 is just 18 is 3 times 6, so 18 is divisible by 6. So that was pretty easy. I couldn't think of such a large number. It's hard to know. Anyway, so if I had 501, 501 is not even, and 5 plus 1 is 6, it's divisible by 3, but not by 2. But we can't just have divisible by one number. It has to be both. So 501 is not divisible by 6. And why is the 7 boxed in? Well, again, warning, you have to use a calculator or something like that. You have to use long division for 7. There isn't 7 isn't very special. He must be crying right now. It isn't very special. So how about 8? Well, 8 is also similar to the 4. 4 is also pretty special. Anyways, so 8, so 8, what's special about 8? Well, what's 1,000 equal to? I know 1,000 is hard to think of it, but 1,000 is actually a multiple of 8, actually. 8 times 125. So if I had a big hunk, like 1,872, I know this 1,000, maybe if I had a larger number, like 72,872. Well, and then this 72,000, that's made of a bunch of thousands. It's made of 72,000. So let's count by 125. It's up, 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 up. So I get to 72,000. So any multiple of 1,000 is divisible by 8. Just like how any multiple of 100 is divisible by 4. That's pretty similar. So all I have to look at is these last 3 digits. Since it's the last 3 digits that we have doubts if it's divisible by 8. So, well, 880 is 8 times 110. If I just go down 1 more 8, I get to 872. So 872 is 8 times 109. So therefore, 72,872 is divisible by 8. That was pretty cool, right? So if I had another number, like 960, it's divisible. 970, that's better. 970, that's not divisible by 8, not quite. So this number is not divisible by 8. Let's try 9. Again, like the 3 already focused on it, sum of the digits is divisible by 9. For example, 9,990. 3 9s, that's just 27. 27 is definitely divisible by 9. But if I changed this 0 to a 1, it'd be completely different. This is 1 more than a multiple of 9. So we get remainder of 1 when we divide by 9. Whatever. So 9 plus 9 plus 9 plus 1 is 28. Not quite 27, so it's not divisible by 9. So for a teeny conclusion for a 9, the sum of the digits have to be divisible by 9 to tell if the number is divisible by 9. To make sure the number even has a chance to be divisible by 9. Anyways, in 10, it's pretty easy, right? You already figured it out by now, right? Number has to end in a 0, of course. So if I had this crazy number, 8, 0, 0, 0, 0, blah, 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 blah. I have all these zeros out there. It still end at 0, wherever the end is. So this, it's divisible by 10, since it ends in all these zeros out there. So what about 8, 0, 0, 0, 0, 1 ends in 1, even though the 0 don't affect its 10. All you care about is the last digit. 1's not 0, not divisible by 10. So again, this 11 is very complicated and I might just pull off into a new topic. So if you really want to know about this 11, I can tell you that later.